Hello everyone, welcome to the lecture 6. In lecture 6, we're going to talk about the soil classification. So far, throughout the lecture 2, 3, and 4, and 5, we talked about the coarse grain soil, the particle size distribution of the coarse grain soil, and also the plasticity of fine grain soil. And when we say the fine grain soil, we normally refers to the silt and clay. And the coarse grain soil in soil mechanics we refers to sand and gravel. So then already we have some group, right? From gravel, sand, silt to the clay. And we can add the symbol, and we can use some symbol to classify the soil with some characteristic. So there are widely used classification system, and today we'll cover the one of them. So soil classification system and the soil classification divides the soils into groups that have the same characteristics which can be related to engineering properties. So soil classification is a kind of language or the terminology in geotechnical engineering. So in practices, people use these symbols and the classification system to name the soil. So in many companies or in many practice in many countries, like your boss can ask you about what's the soil in the site of the interest that we were gonna build a harbor or the airport. Then you can say that to a certain depth it's a sandy soil or silty sand or like clay soil with a high plasticity, etc., etc. So we're gonna talk about the language and the common terminology to classify the soil. There are two widely used systems. One is the unified soil Unified Soil Classification System, USCS, and there's another one, AASHTO, which is developed by American Association of State Highway and Transportation Officials. In geotechnical engineering practices, we typically use this USCS. So today we're going to talk about this one. But the AASHTO system is also very close to the USCS, so they kind of share the same characteristics. So if you can understand how the USCS works, then you'll be able to also catch up with the other system too. So USCS, the basic idea is to group and assign a symbol, and there are two letters, main letters and the second letters. And main letter denotes the type of the soil, either gravel, sand, silt, and clay, and second letter denotes and describe the characteristics of the soil. So for the gravel, we use G as a main symbol, and S for the sand, and M for the silt, and C for clay. So these are the symbols that you use in the USCS as the first letter. And the second letter, for the coarse grain soil, normally the characteristic captures the gradation, how the particle size distributes. So the well-graded soil, we use W, and poorly graded soil, we use P. And if it contains some fine fraction, so you may have a soil that's mostly consisted with sand, but also contains some fraction of the silt, right? In that case, you can use the M if it has some fraction of the silt. Then if it's clay, then you can use C. For the fine grain soil, depending on the liquid limit and the plastic limit, it can have a high plasticity or low plasticity. So if it has a high plasticity, we use H, and low plasticity soil, we use L. Good. Okay, so let's look at more detail how to determine the main letter first. First, we use percent passing number 200 sieve. So the reason that we are using number 200 sieve is the sieve has the opening size of 75 micrometer, and that's the threshold size for the coarse grain soil and the fine grain soil, right? So if the soil passes the number 200 sieve, the passed soil will be fine grain soil and retained soil will be coarse grain soil. So if the 50%, less than the 50% pass the number 200 sieve, then most of the soil is coarse grain soil. Right? If more than 50% of the mass fraction pass the 200 sieve, number 200 sieve, then it's fine grain soil. Right? And for the coarse grain soil here, then for the coarse grain soil, for the main letter can be G or S. So it can be gravel or sand. So then we have to determine which one is the majority, right? So whether the gravel was the majority or the sand was the majority of the soil. So then we have to look at the percent passing number 4 sieve. And number 4 sieve have the opening size of what? 4.75 millimeter, right? So if more than 50% retained on the number 4 sieve, that means that the more than half is larger than 4.75 millimeter. So then we'll define as gravel. Right? So that soil, the major component is gravel, so dominated by the gravel. And if more than 50% pass number 4 sieve, then it will be sand. So S will be the first letter. And if the soil, more than 50% pass the number 200 sieve, then we'll characterize it as a fine grain soil. And in that case, we're going to use the plasticity chart to classify whether the soil is silt or sand. So do you remember this chart, right? So then you have to test and determine the liquid limit and the plasticity index. Right? From there, you can kind of map it, whether it belongs to the CH or CL or the MH or the ML. So if it's above the A line, it's going to be clay. If it's below the A line here, this line, then it will be silt. So then you use the M as the first letter, the main letter. Then the second letter, for coarse grain soil, we look at whether it has the small fraction of the fine grain soil or not. So we look at the percent passing number 200 sieve. If the percent passing number 200 sieve is less than 5%, so then the very small fraction is just a fine grain soil, right? It's very clean. So we'll characterize that. If percent passing number 200 sieve is less than 5%, so then it means that only the fine fraction is 5%, no? Less than 5%. So then we can say that it's a clean soil. So it's not hardly affected by the fine grain soil. So then gradation becomes very important, whether it's well graded or poorly graded. So then we'll test the sieve analysis and determine the CU and the CC, the coefficient of uniformity and the coefficient of curvature, and using that we can describe whether it's well graded or poorly graded. If it's well graded, W, and poorly graded, and P. W. So for example, for gravel, CU needs to be larger than 4 and CC should be between 1 and 4, 1 and 3. So if that soil satisfy these two conditions, then it can be categorized as the well graded. For sand, Cu changes, so Cu should be larger than 6 and the Cc should be between 1 and 3. So example will be if it's sand, then you can say that like sand, and if it's well graded, and SW. So this is well graded sand, or SP, poorly graded sand, or GW, right, or GP, right? Poorly graded gravel or well graded gravel, right? Okay, and if the fine fraction is more than 12%, then your soil contains significant amount of the fines. So then the property of the soil will be also affected by this characteristic of this fine, whether this fine has very plastic, high plasticity or the low plasticity. So then you run the liquid limit and the plastic limit test on the soil passing number 40 sieve and use the plasticity chart to determine if the fines are silt or clay. If it's silt, then you're going to use the M for the second letter. If it's clay, then you're going to use the C for the second letter. So SM means that the majority is sand, and it all contains some fraction of the silt. So silt is sand. And SC is clay sand. Still, the more than 50% is sand, but a certain percent larger than 12% is clay. And GM will be silty gravel, GC is the clay gravel. What if it's in between 5 and 12%? Then we're gonna examine both the gradation and plasticity. Examine both gradation and plasticity. So here from the gradation, we'll characterize it whether it's well graded or poorly graded. And from the plasticity, we can characterize whether it's clay or silt. So if the fine fraction is in between 5 and 12, let's say there's a 10% fine fraction, and the majority is sand, then you do the gradation test and get the CU and CC and determine whether it's W or P, and also run the liquid limit and the plastic limit test and determine whether it's C and M. So then the example will be like this: SW-SM. So well graded sand with silt. Good. Then the other one is this case, when the percent passing number 200 is more than 50%. So that's categorized as the fine grain soil. So then for the main letter will be either silt or clay, or M or C, right? And for that, actually it's very simple. You can just use the plasticity chart. You're gonna run the liquid limit and the plastic limit test and use this chart and see if like CH or the CL, ML or MH. So here the MH is high plasticity silt, or you can say the inorganic silt. And here low plasticity silt, right? So here the silt, inorganic silt of the low plasticity. And if it's here CL, it's a low plasticity inorganic clay. And here CH, high plasticity inorganic clays. And there are some gray area that requires the dual symbol. And here is a silty clay or clay silt. So you kind of share the clay and the silt characteristic both. Huh? Okay. So if you go to the handout, the note, page 4, you will see this chart. And this chart is very useful and you can see that the coarse grain soil with some criteria and fine grain soil with some criteria, and for the gravel, sand, silt and clay, and here in our class and in our course we look at the inorganic soil more, not the organic soil. So don't be bothered by this organic soil. We're gonna focus on the inorganic soils only. So depending on the fine fraction, if this fine fraction is more than 12%, then it can be GM, GC, right? And if it's clean sand like this, and GW and GP, the clean gravel, sorry, the GW and GP, and clean sand, SWSP, sand with fine, SMSC, and silt clay, CL, and ML, and CH, and MH. Good. So that will be all for this class. Thank you.